So hopefully you had a nice lunch and you are not too sleepy. I have a small song for you, just to motivate you a little bit. 1 second. So, I would like to give a big round of applause for our next speaker. Actually, we have an interesting mix. Alessandro here live and Ralph being online.
Yep,
yes,
correct.
Ralph can hear us as well, or?
Ralph, can you hear us?
Yeah.
Wonderful.
Perfect, so we can hear you. And today they are going to talk about Hyperlight virtual machine-based security for serverless functions at a scale. Damn, that's a mouthful.
Yeah.
Very interesting title, and yeah, I have a feeling that it's going to be very
short
low
project
level.
name, long description. Right?
Cool, so let's give a big round of applause for them.
Thank you, guys. All right. So my name is Alessandro Pilotti. I am the CEO at Cloud-Based Solutions, a company based in Timișoara, Romania, more exactly. You can see our name on the lanyard. And then we have Ralph online. Ralph, would you like to say something about yourself?
Sure. I'm a principal product manager. We used to call them program managers. We just make up names, apparently. And I've been around for a long time, well before containers, and was one of the first of a group at Microsoft who was very much into Linux, very much into early container technology, and I helped build the first Docker container service in Azure, and was a member of the team that created Azure Kubernetes service, among other things.
Good, thank you, Ralph. All right, let me set a little bit the context here. So this is something we've been working on for many, many years. But the general idea is that the industry moves forwards towards more efficient infrastructure solutions, as the years pass. So a few years ago, just a few, like 20 or something, we had physical servers. So everybody were running their own workloads on their physical servers and everything. Nobody was thinking that they could actually share, the workloads that were running on those. One server, one workload, like one SQL server, one Exchange, whatever, right? Then we discovered VMs, and VMs became all the rage. We entered the VMware age and so on. So we simply took the primitives we had before, so the concept of an operating system or whatnot, and running it inside of a virtual machine, inside of a physical server. From there, at some point, we figured out, well, you know what? We don't really need all that spec, all that stuff, to run a single process, a single workload. What if we just take the user space components we need, we wrap them up somewhere, and we share the kernel underneath? And this is exactly what kicked off, the container age, which is what, led us to today with Kubernetes, with Docker, of course, and whatnot. Now, from there on, the serverless age started. So the point is like, okay, but I don't really need even all those user space tooling and everything. What if I could just go down to a single process, to running just a single lines of code, the single pieces of software that I need for that particular activity I'm doing right now, right? And that brings us to the current age. Each generation needs new tool. You have to address a bunch of different problems. Of course, there's security that we had in the age of VMs or even before doesn't really work nowadays with modern, security constraints we have nowadays. Performance. You want to be able to run your workloads at a much larger scale. And very important, density in the age of hyperscalers, public clouds, and whatnot, and in the age in which you need to have expensive hardware, expensive costs of electricity and whatnot to share, you want to make sure that your density is as high as it gets, meaning as many workloads as possible on the same server, to say so. Now, moving next, if the clicker works, yeah. This is something we were thinking back in 2018. We started a project called Insula, our common Latin root for isolation. And the goal was to get fast and secure alternative to QEMU. QEMU was having a lot of problems back in those days, because it was not born, it was not created for large type of cloud-native solutions like we have today, right? And the idea was to get rid of that and writing something ex novo, something that could be written in a modern technology like Rust, which has, of course, which is less prone to memory-related security issues and so on. And we wanted to get it to work on both KVM on Linux and WHP, the Windows Hypervisor Platform, on Windows. Beside that, we wanted to get rid also of full-fledged guest operating system, and we wanted to have unikernels for that. That was something that was already an existing technology in those days, and we wanted to make sure we could work on that. How many of you guys went to the Unicraft session like before, right? Yeah. That's an example of a unikernel. Then Firecracker came around. So instead of fighting against them, we decided to join forces and started working with a team, which was also based here in Romania, ironically. So Romania is somehow the capital of hypervisor technologies. And we joined the Rust VMM group back in those days. And then I met Ralph at KubeCon, that I knew since a long time, since we shared the stage at Build a couple of years before, and we started chatting. So Ralph, would you like to say something about the whole Hyperlight story? If you'd like to share your screen.
So can you hear me still?
Yes, we can hear you perfectly well.
Great. I'm going to share a screen. Let me know when it appears.
It does.
All right. So I'm going to say a few things here about where I was when I chatted with Alessandro. Okay. At the time, because I'd been involved in Linux well before containers, when containers came along, they were fantastic and wonderful. But as an engineer, if you deal with them at the technical level, you realize that they're incredibly useful. And they're absolutely horrible at the same time. So you immediately realize that although we can do things with them, and especially when Kubernetes came along as an orchestrator that we could use everywhere, the container solution itself was very, very limited. And you wanted something safe, small, distributed, that was a process that had to be open source, that everybody could use, that worked everywhere, in distributed scenarios all over the world. And that was, in my case, this has nothing to do with AI. This was several years ago. It had to do with WebAssembly. I was really into WebAssembly. In fact, I helped found the Bytecode Alliance Foundation, which you may or may not know, but that supports the development of a WebAssembly component specification in the WS3C. And so I knew that, in fact, the way we ran workloads, as Alessandro was talking about the VM problem and things like this, that serverless was really the right target, and it's still waiting for its proper implementation, which is funny because Lambda and Cloud Run and Azure Functions are super popular services that people run, but they're extremely expensive to maintain, and to use them heavily gets very, very expensive, mainly because the VMs and containers are just too heavy to keep running around. So what you really want is something else. You want something that can recycle the memory and start so fast and yet still be secure for a little teeny workload. Now I'm showing here the sort of problem space from that time. The three that are grayed out are, in reality, those are their hardware boundary offerings. So a traditional VM, and you can see that the cold start is several seconds, and the density is relatively low for a node, which means you have to have a bunch of nodes already running and warm in a warm pool, very straightforward approach, and it gets expensive at scale. So if you're talking about something like AWS or Azure or Google or something else very large, that gets very pricey very fast. And we haven't even started talking about artificial intelligence yet. So Firecracker is a fantastic technology, and this is the time, just after the time that Alessandro and I, or just before, we were talking just after the time where this had really been a great creation with the Rust VMM project, as you mentioned. And Kata containers now in Kubernetes is very good, but not as optimized as it really needs to be. And you can see the density difference there. Firecracker is very good, but if you look at the density of something like Unicraft or WebAssembly with Spin, right, down at the bottom lower right, you can see you're talking about tens of thousands of instances on the same node. And that's the kind of thing that makes a serverless platform profitable to run and efficient for everybody to run. So the problem with Azure, when I was talking to Alessandro, is I can't use WebAssembly in Azure because we have guaranteed our customers to give them a hardware boundary to protect them and to protect us. How then can we start a VM fast enough and small enough to take advantage of the WebAssembly speed, right? And at 125 milliseconds per start, right? And you can snapshot it and make it faster and so forth, but you still, per cold start, you can't start it and then destroy it enough. You're still gonna have a warm pool if you're talking about billions and billions of requests at the same time. But Alessandro mentioned something in that conversation that was amazing to me and blew my head apart. And that was, well, he said, if you don't have an operating system in there, you can start these things incredibly fast, in microseconds. And that changed the way I looked at the problem. So I'm going to hand it back to Alessandro to continue talking about what Microsoft actually became, because when we first ended up building the first iterations of Hyperlight, we shared that with Alessandro and his colleague Alex Ionescu, because we wanted them to make sure that we were going down the right path.
Mm-hmm.
And we still thank both of them for the work that they did to help us create this project that anybody can use. So you want to take that back?
Yes, thank you, Ralph. Wonderful. All right. Yeah, so that's exactly where we were. The colleague, the person Ralph mentioned was Alex Ionescu, also from Romanian origin, and he's one of the key architects in CrowdStrike, right? So, and a big name, of course, in everything which is Windows internals. So it was a wonderful team work. Now, getting to Hyperlight, so this is what Microsoft came up with afterwards, out of those ideas we were discussing. The idea was like, okay, how low can we go in the infrastructure stack to take out everything that we don't need? And that's how we ended up with micro-VM runtime. So the tiniest possible wrapper around KVM, WHP, MSHV partitions. So you want this to run on KVM, on WHP, and MSHV, which is basically Hyper-V on mainline Linux, right? Extremely lightweight, so it has to be embeddable in any application. You don't want a full-fledged, user space hypervisor type of solution like UEMO that you have, like a virtual machine manager. You don't need that here. You want high-density workloads. You want to have gazillions of those things running in parallel. Minimal guest code, no OS, no std-lib, no file system, no network, unless explicitly provided via host functions, okay? So you want this thing to be fully isolated unless you decide what can jump out of it. Built-in Rust, security and sandboxing by design, fast, workloads has to start in milliseconds or microseconds if your hardware lets you do that. And it's a CNCF sandbox project, so fully open source and meant to be used by everyone. Yeah, go ahead.
Can you reshare the deck as you present? Because I want to watch too.
Yes. Come again, sorry?
Reshare the deck, the presentation that you're showing, because I want to watch.
Okay, wait a second.
Apologies to everyone. This is interesting.
Okay. I can send you a video recording afterwards.
Go ahead and continue if you need.
Okay, here we go.
There it is.
Yeah, sorry, I don't know how it happened, but yes, good. So Ralph already mentioned there are a few free open source software alternatives there. Rust VMM, Firecracker, Cloud Hypervisor, so those are all built on top of Rust VMM. They are much slower and they're focused on Linux OS guest. So the idea is to spin up an actual Linux guest, skim down to the bare minimum, but still a full-fledged Linux guest, right? gvisor, which is a thing made by Google, which doesn't use virtual machines, it just intercepts all the syscalls and redirects them somewhere else. Great for isolation, but not, of course, as good as having the, golden standard, which is virtual machine isolation, right? By that I mean VTX type of stuff, right? And Kata containers, which is also another technology that came out a bit before, which is great if you work on CRIs, let's say on Kubernetes, but it's very good for Kubernetes, but it's also much slower for the type of targets that we are looking at. So here is an example of how the interaction between host and guest actually happens. So it's very important when you talk about virtual machines or partitions, like we prefer to call them, technical terms, is that there is a boundary that whatever runs inside the guest cannot really cross unless it's allowed to, okay? Not getting into the details, how this is possible, how the CPU instructions needed to do that, but let's just say you need to put some code and some abstraction in order to do that easily. So the VM boundary is very important. And what happens is that Hyperlight abstracts all that in a very smart way in which you have functions that you can call both on the host and on the guest. So whenever the host wants to call on the guest, it will call into some function which is published, of course, by the guest code, right? And the same thing for the guest. Whenever it wants to call into the host, it will call one of those published functions. And then from there, you can start from a hello world type of thing, like you see in the simple example here, in which the guest has a function which adds two integers, right? And the host will simply print it, And you can take it from there, creating the most complex networking, storage, and AI solutions, right? As we will see very soon. Now let's talk a bit about performance. So spinning up a VM, a host partition, it's already super fast as it is right now compared to a traditional virtual machine, because you don't have to spin up a full-blown guest operating system, but you can do much more. You can, for example, take snapshots, basically copies of the memory used by those quote-unquote VMs, let's call them micro VMs, okay? And whenever you want to create a copy of that, you simply copy the memory, and off you go, right? So there are various technology under the hood that do that. Guest-aided copy and write snapshots is how we call them, and they can give you a massive performance improvement for repeated execution of a workload, which is exactly what you do in typically any type of server situation, You're serving some content from your, internet cloud resource, right? And you have a bunch of users connecting and trying to get the same resource. Not having a guest OS, it's also very important from a security standpoint and in terms of the limitations that this type of snapshotting can let you do. Because if you do that for a full-fledged guest operating system, like for example Firecracker does, you have to fight with a technology which is built in Linux, which is there for a very good reason, and it's called KASR, Kernel Address Space Layout Randomization, which is something that for security randomizes internal addresses, okay? If you don't do that, you create a security risk. We don't have that because we don't have any guest operating system. Okay, now enough talking, let's go to an actual demo. So what I'm spinning up here, it's an Hyperlight instance, serving some content over HTTP. And now I'm going to benchmark in a separate terminal how fast this is going to happen with the type of snapshots I mentioned before. So this hey command will repeat 5,000 requests that will spin up 5,000 VMs, okay? One at a time, okay? Gata. That's it. And here on the back, just to show that I'm not cheating, you see the actual code being executed on the server, which is simply logging from within, Hyperlight. Whenever you have one of these things spinning up, it logs an information, including a timestamp, and this hello CND Romania 2026. I'm executing inside a VM in warm mode. So let's repeat it one more time. That's it. Here you have the statistics. Let's look at them. Well, the average was so fast that it doesn't even clock. The whole total time was 0.24 seconds, okay? For 5,000 VMs. Okay, they don't do anything important, but it shows how the amount of time needed for, all the plumbing in spinning up a VM and everything can be reduced to nothing. And I'm not running static workloads, so this is not, just a cache copy. I'm actually running code inside of each one of those VMs, as you can see from the fact that each one of those is showing a different output. Now, if I repeat the same thing without the snapshotting, it's still going to be fast, but on a completely different order of magnitude. So this is the code. You see things are going still really fast compared to the fact that each one of those lines which are spinning, like matrix type behind there, is still one virtual machine, right? It's going to take probably around 10 seconds to do the whole thing. So snapshotting changes radically the way in which we can manage this type of workloads. And the fact that we don't have to deal with a guest operating system changes also significantly the way in which we can do that. Okay, now I think it's enough time. Should be almost done.
You sure?
All right. So, what you've been doing, Ralph, today? Anything interesting?
I've been looking at you finishing off the touches of this work.
Okay.
It's been great.
Yeah.
And I got my stuff on my side to show in a minute.
It's not that the demo is not working. It's working. It actually serves exactly the purpose of showing that the cold ones are much, much slower than the warm ones, right?
I think if you
there it is.
Get
Gata.
oh, there he goes.
There he goes. So the average in this case is still super fast. We're talking about 0.1 seconds, right? 1 cent of a second. And look how much time it took compared to the 5,000 you saw before. So this is a complete game changer in terms of what can happen.
Now, if I mention something,
yes.
I mention something? Alessandro?
Of course, go ahead.
So one of the things, show the screen again with the VMs. One of the things that's interesting about this demo is that the size, the memory footprint of the snapshotting experience there, it turns out that the actual memory consumed in that environment is recycled as we destroy the VM that you just used, or return it to a warm pool, for example. And that means that what you can do is actually maximize your CPU, because most of the problem here is now not memory consumption. You can actually pack more of these into the same memory space, or the same node in this case, and just keep packing them until the CPU comes to the 80%, 90% range. If you can do that in a serverless environment, your price goes down, and that's what we want.
Okay. Thank you, Ralph. Okay, I'm going now quickly to the next section because we are a bit short on time, and I want to get very quickly to the last part, which will blow your mind. Okay, quick mention about the fact that you can have much more complex workloads already out of the box. One of those are the WASM-based or unikernels, meaning that you can run any type of code, C, C++, Rust, Go, .NET, Python, and whatnot, right? Either with WASM, that will require a little bit more work to make it function, or with a unikernel. So I have an actual demo here with Unicraft that will do the same thing. And just to make sure that it's clear the difference, Unicraft is the guest component, and Hyperlight will handle the host. So there is no overlapping between those two technologies. They're very different, right? Okay, and I will skip that for the moment to go straight to the most important thing I wanted to show you here. So what can we do in the age of AI with this type of technology? One might think that it's useless because the type of workloads you run in machine learning, both for inference and for training, are massive. It doesn't really matter if you spend a few more seconds spinning up an operating system or not. But there are a significant amount of innovations, a lot of innovation that happens with technologies like OpenClaw that are bringing agentic technology, let's say, in everybody's life. And those are a lot of tiny little bit of workloads that spin up all the time, and they are extremely unsafe, because unless you want to let an AI run some random code on your computers, having full access on all your data, that might not be a very good idea. And that's where exactly Hyperlight fits in like a glove. So it will simply allow you to take those workloads, that code that is actually generated by by your AI tools, your AI models, and wrap them in a sandbox, telling exactly what they can do and what they cannot. Here is a quick example. You ask a question, LLM writes JavaScript, code is validated, code is executed in a micro VM from Hyperlight, and that's it. Okay, here is a quick outlook, how it looks like. Going through this because we have only 5 minutes left. Extending HyperAgent is very easy. So HyperAgent is the name of the project here, which is still part of the Hyperlight group of repositories online, if you go and see it. You have plugins, which add new host capabilities, skills, which add domain expertise, models, which add sandbox utilities, patterns, which add code generation guidance, profiles, which bundle resource limits and plugin requirements to name presets, and MCP, which allows you to access pre-configured MCP servers. All this can be written in JavaScript and TypeScript or just configure it in JSON. MCP, for those of you not knowing it, MCP is just a technology, a plugin interface for the AI age, so that anybody can basically add new services that can be consumed by this type of services. Okay, here's a slide about Copilot that I can slide. You need a code token for Copilot for using it at the current stage to access it. I'm not running it because right now they stopped. You cannot subscribe to Copilot right now for at least another month. So I'm almost out of tokens, so I cannot do the right demo. But Ralph recorded it already. And since we are a bit short of time, I can play it. Ralph, would you like to run it live, since we have like 3 minutes left, or would you prefer to run the video?
Why don't you run the video and
okay.
I'll talk through it really quick.
Yeah. Okay.
All right.
Yeah.
So this is an example. It's just an npm install of HyperAgent, which is the agent that Alessandro was chatting about. And so if you want to run this, you can run this, no problem. This is an example that offloads your token spent into code generation, and then it has the code executed in a Hyperlight sandbox. And so this is a general experience. One of the critical things about the experience is just to make sure you understand you have a complete control over everything, although I do have to type help correctly. And so you can see you have all kinds of power over timeouts and MCP servers and profiles. And so you can list the models. You see in this particular case, I'm using Opus 4.6, and I have to type profile correctly. And you got a whole bunch of different profiles, heavy compute, default, web research, and so on. So you also have modules. You also have to make that singular and list them, which I always forget because I'm old, and that's the way it happens. But you can see you have tons of tools, and you can create them on the fly with HyperAgent. So here's an example. I'm going to examine a repository for organizational forks of a particular thing. In this case, I'm looking at LLMD, or maybe I was looking at KServe, but I'm going to look at both of them. And so it's going to say, hey, we can do this. I'm going to do it again because I did it the wrong time the first time. And it first asks you, this is sped up a little bit, as you can imagine, to confirm that this plugin is okay. So there it does it. And it actually created that in an Excel spreadsheet for me. That's not terribly interesting. What's more interesting, I want to do that and ask it to do the same thing with another repository. So KServe, for example, an AI inferencing project. And so it goes through and does that stuff. It figures out all the code, but all of that stuff gets executed in a secure Hyperlight sandbox. And so here, I get another one. And I can go ahead and open this straight away, just by asking it to open that. It goes ahead and spawns it. There it is. And now I can look at all the organizations, not individual engineers and so forth. And I can create a fantastic little report on the fly of all of these queries, so you can do iterative work to build something that's complex and useful. And the red stuff there is when the model created code that didn't do the job. It errored out in some way. And the model itself will go fix it, which is fantastic. So now I got a PDF. Great. Okay, but PDF is good for general sharing and so forth. I happen to be at Microsoft, or if I'm in another office environment, I really want a PowerPoint. So I'm going to take that same PDF and I'm going to say, hey, make me a PDF for that, a PowerPoint for that. And so I could do that right away. All of that work happens not on the token time. All of that work happens in code, which is cheap, and it's isolated code in Hyperlight. And that's why that works well and saves you money on tokens, even if tokens are pretty pricey these days.
Wonderful. Thank you, Ralph. We finished exactly on time. Okay. Thank you very much, everyone.
Cool. Thank you very much for this presentation. It was pretty low level.
Yeah.
It felt.
Could have gone lower than that when we restrained ourselves.
Yeah, I have one question for you.
Sure.
If you were to describe Hyperlight in a couple of words, 2 words, like ta-da.
Virtual machine-based security for serverless functions at scale.
Cool, nice. So this is the kernel of the talk. I don't know, guys, if you have any questions. Please raise your hand. Any curiosities? Okay, there in the back.
Thanks for the presentation. It was excellent.
Thank you.
Can you tell us a little bit about the limitations or lack of capabilities or capabilities that we have in these micro VMs? For example, I don't suppose we can run Docker in it, right?
That's not the purpose. Let's say those are completely different technologies. You could theoretically get to a point even to run that, but at that point you will minimize the advantages of running that, right? Because in the end, the whole idea of these micro VMs is to leave you an empty canvas in which you can put whatever workloads you want, right? Yes, you could put extremely complex workloads, including Docker, but at that point, the amount of time you save in spinning up those micro VMs will not really make that much of a difference. So Hyperlight is not meant to replace Docker. It's meant to address a completely new set of workloads. As I mentioned before at the beginning, you have containers, and Docker is perfect for the container age, and so is Kubernetes. And then you have this type of micro workloads for which micro VMs are much more suitable, let's say. I think maybe Ralph wanted to say something, or?
Yeah, it's a new tool that you can use with the tools you already do. If you need, container integration right away and so forth, then you use containers. If you want to run something for a long time, like more than 5 minutes, then the start time is not terribly important to you. It's really about how useful the environment is. And so for something like that, Cloud Hypervisor and Firecracker are fantastic technologies to have a full Linux workload running. This is for something much more opinionated, much faster, much denser. That's why it's different.
Cool, thank you. Any other questions? Cool. Oh, another one here, please.
Hi. So you said earlier that you can run tens of thousands of micro VMs, right? What is the limitation? Do you have problems with limit of inodes or TCP sockets, or why don't you increase that to more?
Well, of course, the physical limitations from the underlying server still exist, right? For example, okay, now I run them in sequence, right? If I will run them in parallel, I will hit the limitation of the number of cores I have on that particular machines. You mentioned TCP sockets, right? Hyperlight does not handle TCP sockets directly. What you saw in the demo includes also a wrapper that has its own, let's say, HTTP REST API endpoint, right? But that could be completely replaced, for example, by Nginx, no? And that layer will not be handled at that point by Hyperlight because it's not Hyperlight's business, right? So Hyperlight has the advantage that you can decide which bits or pieces you want to handle within that process itself and which one outside, delegating it, for example, to software that does it already much better. There is absolutely no reason on Earth to reinvent what Nginx or Apache do pretty well, right? And similar. Another interesting thing related to that, you might also want to limit your workloads to some limits. For example, you want your VM not to be, your micro VM not to exceed a given amount of RAM usage or CPU usage and whatnot. And this is exactly where, for example, the HyperAgent demo does. You don't want those workloads to escape the boundary of that micro VM, and you don't want it also to hog all the resources on your CPU. So not only you're not limited specifically by Hyperlight in that, but you might want to limit what your workloads can do, right? Exactly like other similar VM-based technologies. Okay.
Cool. Any other questions? No. If
Okay.
not, thank you very much, Alessandro.
Thank you, guys, and thank you, Ralph.